Hypothalamus artificial intelligence, HI. Digital transformation powered by real-time autonomous and intelligent algorithms. Presence high gas, natural gas supply chain optimization, an artificial intelligence-based decision support system oriented to agents acting in natural gas markets. Optimization of natural gas networks. There are many applications of mathematical models of optimization of natural gas system networks. Basically, for all applications the same model is used, from different points of view, which entails adjustments in the mathematical modeling. Some of the applications are: natural gas market simulation, natural gas market and system regulation, real-time optimization of natural gas pipelines, and optimization of natural gas systems. The Natural Gas Market Module, NGMM, is the component of the USA National Energy Modeling System, NEMS, that represents the North American natural gas transmission and distribution system, and market. The module is a quadratic program that maximizes consumer plus producer surplus minus transportation costs. The consumer surplus represents the amount of money saved by consumers, who would buy natural gas at a given price but are able to obtain it at a lower one. The producer surplus represents the added revenue of suppliers, who could sell natural gas at a lower price but are able to charge a higher one. Therefore, by maximizing this combined surplus, and subtracting transportation costs and subject to balance and capacity constraints, the model arrives at an equilibrium price for the market. The image presents the NGMM natural gas pipeline network. Purdue University's SUFG, State Utility Forecasting Group, has supported experts from the Indiana Utility Regulatory Commission, IURC, since late 2001, with the goal of examining the impact of new electricity generating facilities within the gas system. The model determines the mix of purchasing, transportation, and storage decisions of local distribution companies, LDCs, which minimize the sum of purchasing, transportation, and storage costs over a 60-month planning period, subject to the following constraints. Consumer demand at demand nodes must be met. The flow capacity of gas pipelines should not be exceeded. Storage capacity limits of storage sites should not be violated. The amount of gas transferred from one pipeline to another cannot exceed the capacity of the interconnection, and long-term purchases and dispatch contracts. The image presents the network topology of the gas modeling system. Real-time optimization of natural gas pipelines. Nowadays, natural gas is one of the primary energy resources employed in many sectors, and it can be regarded as a bridge fuel in the decarbonization process. The transport of natural gas relies on a complex infrastructure, which needs to be properly managed to minimize energy consumption and CO2 emissions. The performance maps of the gas turbine-driven compressors have been linearized using the convex hull approach. The model includes all the technical limitations of the gas turbine-driven compressors, and it can handle flow reversals on all pipes. Moreover, it is suitable for cyclic networks. The MILP model is applied to a case study with 4 compressor stations, each containing multiple gas turbine-driven compressors, and a cyclic network consisting of 29 pipes. In this case, the MILP model was used to optimize the 24 hours of unit commitment, with time resolution of 30 minutes, and sections of a maximum length of 200 kilometers. The continuous variables of the MILP are 18,816, the binary variables are 1,421, and the constraints are 43,429. The optimal unit commitment and load of the gas turbine-driven compressors, GTDC, is shown in the figure. The solution uses only one GTDC of station S1, 3 GTDCs of different sizes in stations S2 and S3, while station S4 is always in the bypass mode. The optimized solution features an objective function which is 7% lower than a preliminary solution found by fixing the commitment of the GTDCs S1 S3, optimizing only the loads. Optimization of natural gas networks based on stochastic optimization. This model provides a review on the most relevant research progress, related to the steady-state operation optimization models of natural gas pipelines as well as corresponding solution methods based on stochastic optimization algorithms. The existing operation optimization models are mixed integer nonlinear programming, MINLP, modicil, involving a non-convex feasible region and mixing of continuous, discrete, and integer optimization variables, which represents an extremely difficult problem, to be solved by use of traditional monolithic optimization algorithms. However, no reference is made to advanced methodologies using large-scale optimization methodologies. A schematic of a natural gas transmission system can be conceptualized based on three subsystems: gathering pipelines, transmission pipelines, and distribution pipelines. The images shows a gas pipeline network composed of a tree and a cyclic network. The real-time model can handle differentiated electricity costs by time of day, or by load block, using this way to take advantage of low rates, or low marginal costs, in periods of electricity low load. A gas pipeline is a pipeline that allows combustible gases, natural gas, liquefied petroleum gas, to be transported on a large scale and over a long distance. Pipelines planning and scheduling. The optimization model includes the following types of nodes: production fields, consumption center, natural gas demand nodes discriminated by demand sector, among which are industrial, vehicular, electricity generation, commercial, and residential, and ports and terminals that can receive and/or send LNG. It is associated with liquefaction and/or regasification plants. Those interested in learning more about modeling gas piping systems are invited to watch the video. Oil pipelines optimization. Electricity and natural gas integrated modeling. High power integrates the following models. High electricity supply chain optimization supports decisions in the electricity supply chain, in terms of sectoral planning and business generation. High smart grids optimization supports the decisions of the various agents involved in the smart grids business. High natural gas supply chain optimization supports the decisions of the actors involved natural gas supply chain, at the level of sectoral planning and business generation. The following is the topology of high power. Hydraulic system physical modeling. High water corresponds to a general model that includes all kinds of hydraulic components: reservoirs, hydroelectric power plants, rivers, overflow channels, connection points and pumping stations, demands, like irrigation, aqueducts, environmental, industrial. Components can be freely linked to form any topology, like pumping storage systems. Hydroelectric power plants are modeled independently of reservoirs, so plant-reservoir connectivity must be established. The regulation capacity of the reservoir is simulated in detail, so such a simulation consistently represents the dispatch of the power plants, considering their ability to regulate the multi-annual, annual, hourly water resource. Electric system physical modeling. Electrical connectivity is carried out through a network of circuits and bars that integrates different types of installations, power plants, like hydroelectric, thermoelectric, coal, wind, solar, biomass, places of demand, like industrial, cities, regional interconnections and energy storages. High power includes the simulation and several types of renewable energy sources and energy storages. For each type of electrical asset, high power includes the exact equations for simulation. Natural gas system physical modeling. High gas describes the process of supply and demand of natural gas. From this point of view, its integration with the electricity system determines the economic equilibrium electricity-gas markets. The entities of the natural gas system are: node, connect the gas system installations; production fields; consumption zones, discriminated by sector, example, refineries, heavy industries, residential, vehicular, and commercial thermoelectric power plants; transport systems, I, pipelines and II, multimodal transport systems using vehicles, pumping stations, compress the gas to transport it, and ports, receive and ship liquefied natural gas, LNG, and have gas storage capacity. Connectivity between the electricity and gas sectors occurs through the demand for natural gas for use in thermal plants, and the substitution of the demand that can occur between gas and electricity. High power, autonomous optimization software for energy sector enterprises. It is an optimization decision support system aimed at agents acting in the energy sector, understood as the union of electricity, natural gas, oil, bio-renewable sources, and new non-conventional sources. For more information, interested parties are invited to watch the video High Power. Use case: Oil Express Natural Gas Field Exploitation Planning. At the end of the last decade of the last century, Oil Express, a global natural gas company that operated several natural gas producing fields in multiple countries, asked High for support to define a natural gas field exploitation planning strategy, using highly complex mathematical models, to analyze the entire decision-making environment. The challenge was to develop a model that supported the decision-making regarding the exploitation of natural gas field and its impact on Oil Express finances. Solution: Design and implementation of a DSS for management of natural gas oil field strategic decisions like the exploitation period. The models included in the DSS were: Electricity and gas economic dispatch simulation, optimization of the gas trading decisions, optimization of the financial and fiscal decisions, and financial simulation of the gas buyers. Result: the SHTG model, hydrothermal and gas system, the first version of the actual high power model. Based on the high power, Oil Express makes its decisions that produced successful results that led to higher profits by delaying the exploitation of the gas field for an economically more convenient time, due to the non-sustainability of the market. People interested in the case can watch the video, Oil Express, Natural Gas Field Exploitation Planning. Success case: China National Petroleum Corporation. The paper Operations Research Enables Better Planning of Natural Gas presents the use of mathematical optimization models for pipeline planning. China's natural gas consumption has nearly doubled in the past 5 years. To better meet demand, the China National Petroleum Corporation, CNPC, China's largest producer and supplier of oil and natural gas, partnered with researchers from the University of California in Berkeley and Tsinghua University in Beijing to apply operations research to develop and implement new software to help CNPC to improve the management of its pipeline network. Previously, all pipeline production and construction planning for CNPC, which controls 72% of the country's natural gas resources and 70% of its pipeline network, was done by traditional methods using spreadsheets. However, due to the increasing size and complexity of the network, the use of the traditional method resulted in excessive costs and wasted resources. Since implementing the new software, which uses a 3-stage convex relaxation method and iterative piecewise linear approximation methods, in late 2014, CNPC has obtained approximately $530 million of American dollars in increased earnings, 2015 to 2017. In addition, the resulting increase in the efficiency of the existing pipeline network allowed the company to postpone the addition of new pipes, leading to an official budget reduction of more than $20 billion of American dollars in construction costs for the following 5 years. The image present the algebraic formulation of the natural gas pipeline transmission model. Without fear of being wrong, it can be said that mathematical optimization models are the goose that lays the golden eggs of China National Petroleum Corporation. Like Herbert Simon, hypothalamus artificial intelligence believes that the computer-based mathematical modeling is the greatest invention of all times. Thank you for your attention.